Hey everyone, how's it going? Welcome to the stream. So, why don't we go get right in? So last time we were working on our RST parser. We basically had gotten to the point where we were parsing the source file and line number directives, and the next bit was to get into parsing the instructions. So since 2 days ago, I actually did a little bit of work. So this is where we were last time. I'm going to check out the version with my latest changes. Hey Jono, how's it going? I have been well. How are you? How have you? Great. So as you can see, this file suddenly got a lot smaller, and that's just because I started splitting things out. I think I need to do a generate cache for CMake. And I'll show you exactly where I've moved things. Not very complicated. Let's see, still parsing. All right, here we go. So basically under the debugger here, I have added a file for the debug symbols. So I just moved source location and debug symbols in here. And I added a RST parser. So this is where that code has moved. Now I made a couple of changes to this. So let me go over that really quickly. I renamed my states. So now I have parse directives and parse line instructions. What we had done is basically this last time. And we were printing the current source file along with the line numbers. And at this point, when we realize that we've parsed a line number directive, so just to go back here. So this is an example of a line number directive, right? So this tells us that the next section, all of these instructions here, up until the next STABS, right? All of these instructions are for this line number. So what I do is, as soon as I've matched a line number thing, I switch states, my current state, to parse line instructions. Okay? And I started writing this one because it's not very complicated. So the next bit I have to do is continue to parse lines, and now I need to parse out instructions. So you can see that over here is I do a regex match, and I'm looking to see, is this line an instruction? So I have a new regex here to match instructions. This one here, I'm mainly basing myself on the fact that there's a square bracket here. These two square brackets, I think, I'm hoping that I got that right. Like if I do this here and actually escape the square brackets, see, this is basically what we're matching on. I think that basically only covers instructions, because it's not really obvious to know, if you got an instruction or not. I don't think obviously I could sort of say, okay, well, if it starts with maybe 4 digits, I could say that's an address. Maybe I could do that to beef it up a little bit. Then there's some number of, pairs of addresses here, actually bytes, because each one of these represents like the byte code for the instruction itself. Then there's the square brackets here with the number of cycles, followed by some arbitrary line number in this RST file, followed by the disassembled version of the instruction, and potentially some comments. So I'm currently basing myself on this, and I am matching their very first bit, because this here is the address. So I guess I could make that slightly better, because right now I'm sort of just I'm eating up dot star here. I could, I guess, do like, if it's 4 hex values, then followed by from some white space, all the way up until I capture here. What am I capturing here again? It's the, I have 2 captures. Why did I capture 2 things? I don't even know. Was I thinking of, I do a capture here for the address. Then after that, space, then just before, did I need, I think I'm needlessly capturing here actually, now that I think about it. Yeah. Guess I wasn't thinking that one through, right? Capturing the bit just before, yeah. Don't really need that. And like I said, like here, I guess I could do, you know, instead of dot star, I could say, it looks like it's always 2. I don't think we ever have something that takes more than you know, 99 cycles. So it probably is okay to do this. So maybe I could do that. And like I said, what I'm trying to capture here is an address. I think if I wanted to do that, I could say like it's A to, and is it always capitalized? Looks like it is. So it's either like 0 to 9 or A to F, right? And then I'd have to put that sequence 4 times. Like that, you know, that would be another way to say I'm capturing the address. We could try that. Let's just see how that looks. Okay, so let's say we match an instruction. Right now, what I'm doing is I'm grabbing that first bit of the match. I am doing a string to integer and saying it's a hex value because it is a hex value. And I'm taking that as the address. So here right now I'm just printing, I found an instruction at this address. Otherwise, I'm trying to match basically any stab line. I'm considering that to be like we're done for this line directive. So this here is another match any stab directive. So here here below I was matching specifically the stab S, the string directive, and the stab D for the dot. This here is just match any stab. So it's dot star looking for dot stab, you know, very simple. Okay, if I do match one of those, I go back to the parse directive state, okay? And I also added this bit here of reparse current line because this line that I just parsed, I want to parse it again in the parse directives. So that's a cute little trick where I have a bool at the top here that just says reparse current line is false, and my while loop says while reparse current line or get a line, right? So this is to short circuit the get line. So I always start by setting it to false inside the loop. And then if my current state says, okay, set it to true, which should happen rarely, but say my state says set it back to true, it means the line that I just read, I'm going to switch states. I want that line to be parsed again. So we're going to come back to the loop. This will be true, so we won't do this call here. So we short circuit this condition, and it goes back to false. And now we'll be, let's say, back in parse directive state, in which case the line that we match against is the one that was here. So that's what that little trick is. Okay, so let me just show you what this actually looks like. Now, assuming the changes I just made to the instruction actually works here. First time I build it since I check it out, so it's a bit longer. All right, so let's get this launching. One thing I noticed, at least on my laptop when I was working on this, is that this parsing is extremely slow. And when I did a bit of profiling, it was like right now, you can see that it's taking a very long time. Unfortunately, the slowdown is in the regex stuff. I'm not going to worry too much about performance right now, but there are definitely things we can do to speed that up in the future. You know, anything from like I could do stuff like caching my symbol tables. You know, all the symbols that I'm going to be extracting, I could just sort of cache that in a file, and you know, I would have to store the timestamps of the RST files to know whether or not it's worth reparsing them. That would be one thing. I could also I could like do, you know, multi-threaded parsing because each file could be parsed independently. If I do that, well, either I'd have to put locks on the symbol database, right? or I'd have to do something like just sort of collect the symbols from each thread and then take them all and put them together into the database, which is probably what I would do so that they parallelize better. So there's all kinds of things we can do, but I'm not going to worry about that for now, because right now it just means waiting a few seconds. I think, you know, we could wait a few seconds. So here you can see the output. So let's go a little bit higher here, and we can sort of start at the top. So as an example, to see that this actually makes sense, we can see that when we're parsing base.rst, we are in base.h at line number 45. So let's do that. Let's go get, this is base.h. I'll move it over here. So we're saying, and of course we don't mean line 45 in this file. Oh, sorry, actually it's not this file, it's base.h. Yeah, so here we go. Base.h, line number 45. So here we go. So it looks like we're parsing memcopy, and it's saying, you know, we've got, for line 45, we've got these 3 instructions. So this must have to do with the setting up of the stack for the input arguments here. We can see that we should be skipping all of this code here and going straight to 53, and that's exactly what we see there. And for line 53, we're doing like, looks like we're doing 2 instructions. One at 01DA, one at 01DC. Then at line 54, we have these 2 instructions, or 3 instructions, I suppose. Yeah. So anyway, this basically, you know, shows you that it is working. So that's great. And I just wanted to like sort of talk a little bit about what I started talking about last time, which is using variant here to manage a state machine. I know it looks maybe a bit complicated, but I just wanted to talk a little bit about the benefits of doing it this way. So one of the things is that we're using variant, right? And the idea behind a variant is that you can only ever have one of these types in the variant. So this represents, you know, in effect, where we have a state machine over here where we can only be in one of these states. Okay, that's the idea. And what's cool is that each state is represented by a class, or a struct in this case, doesn't really matter. And what's interesting about that is that each state can have its own state data. It's true that in this case we're repeating source file, but that's okay. You know, in this case it makes sense, but like for instance, when we're in parse line instructions, so we're parsing the instructions for the current line, we have this line number value here. This only makes sense while we're in this state, right? As soon as we leave the state, this line number value means nothing. Like in parse directives, there is no such thing as the current line number. If we go back in the state machine, you can see what I mean. We're parsing directives, and at one point we've parsed a line number directive. So we grab that line number and we say switch to the state and feed it to that line number. Like we construct the state with the current source file and the line number. So this line number is now scoped to this state here. So now we're in this state, and in there we use that line number. You can see here st.line somewhere, right? Where is it? Actually, I think I'm not even using it yet, but we will, right? Because what we're going to do now is, this is just printing, but what we're going to be doing is we're going to be adding entries to our symbols, and we're going to say, for this address, create a source location for the current file and line number that I'm currently storing. But then once we leave the state and go back to parse directives, we lose that line number, and that's great because we don't care about it. Typical state machines that we would write pre-variant, or let's say in regular C or C++, we do something like we'd use an enum to represent each state. So we don't use classes, we use enums, which don't really have state attached to them. And we'd find ourselves basically declaring all these local variables, some of which are used in some states and some of which are not. And you have to be always careful about like making sure you don't read the wrong variable in the wrong state, or resetting the value of a variable. Like one thing, we don't really need it here, but you know, imagine that there's a variable in here that we don't set upon entering the state, but that we may set during the state. We know that we can take advantage of the fact that being a class, it will, have a constructor and it'll initialize those variables. We could even add a constructor to the state. So we get all the benefits of having a proper class. We get RI, right? We could have constructors, destructors. We get scoping. So there's a whole bunch of really great benefits to implementing state machines with variant in C++ 11. So I just sort of wanted to, I guess, talk about that because I sort of started talking about it last stream and didn't really get into the details. But it's a how can I say, it's something that I've been messing around with because I find myself, when you're programming, you often have to write state machines. I've actually written my own hierarchical state machine C++ library years ago, and it's on my GitHub. So I'm obviously interested in that. And being able to write one like this that's pretty powerful. I mean, it's flat, it's not hierarchical, but if you have to write a flat state machine and being able to use the language to help you, I find that pretty cool. So I'll end the rant there. Okay. So what's next? So, all right, all this printing is cute and all that, but that's not really what we're here for. So let's say we get rid of the printing. So what we really want to do is start adding to our database. So we actually store our debug symbols pointer here. So what do we want to do? So let's say we've matched an instruction. We basically want to do an add source location where we say add this address, and we want to create a source location. Whoops. Now source location, if I recall, is only 2 fields. It's file and line. No big surprise there. So I'll say, I can actually just do this, file and st it's st.file, right? Is that what I called it? Oh, source file. And st dot line number. And there we go. So just with that line, we've presumably have added, what is it saying? No instance of constructor source location matches the argument list. Arguments are type std string and uint32. Std string and uint32t. Oh, I know why. It's because it's a class. Yeah, I'll make it a struct because those are not public. That should work. What is it? It doesn't like here. Too many initializer values. So I should be able to do this. This it likes, right? Or not? Oh, okay. Oh, I see. What is it that it doesn't like here? Source location is not a type name. Let me just use the compiler rather than rely on this just to see what's going on here. Compile's just fine. So this is just Visual Studio being weird. Okay, so there we go. Hopefully it'll sort itself out. Maybe I'll regen the cache. Because I know the IntelliSense database will get refreshed after I regen the CMake cache. So hopefully this will wake up at some point. Let's see. Oh, okay, there we go. No more squigglies. Everything looks clean. So one thing I added here as a to-do is whenever I add a source location, it's possible that we're going to rewrite the same source location info at a given address. Technically speaking, we should never write something different, right? So I was saying here to-do, if there's already a location object at address, validate that it's the same as the input 1. So, I guess it would be something like I don't know if it should be a C assert, but for now I'm just going to try this. So assert that either locations of address dot file is empty, or if it's not empty, that it's basically equal to location. Something like this. Doesn't want, oh, it doesn't generate an equals equals. All right. I suppose while I'm at it, okay. So let's see how this goes. So it should be parsing. Now we're not going to see any output, but I just want to see if we hit any asserts. And looks like we don't. So that's great. We've parsed all our files. Apparently we have all our symbols. Yeah. All right, so great. What's the next step? So the next step is, the way I'm doing this right now is not clean. So the DAP debugger is going to want to have its own instance of debug symbols. Because obviously that's the whole point. The debugger is going to be using those symbols to feed the DAP protocol. Okay, so basically this is going to change into m_debug symbols. I think I'm going to have to add my debug thing up here. Debug symbols, I'm going to move it to this header. Yeah. And we parse. Looks good to me. To be honest, this RST parser sort of holding on to debug symbols as a pointer and all that isn't really necessary. So I'm contemplating just like making a regular function here, and we pass it the path and the debug symbols. The only reason I was doing this was because I thought I might break this down. Maybe if this gets a little too out of hand, it might be worth having it to be a class. But right now it's kind of one of those useless classes, you know? Like, it doesn't need to be a class, but it's okay. I'll leave it like that for now. Okay, so let's say we've done all our parse RST. Let me just put a little breakpoint here, because I want to look at what the debug symbols looks like. I think it's unused variable problem. Yeah. What I expect is that, you know, we are actually storing a pretty large array, like 64K array, but in reality, we don't really need that much. All symbols will have to reside in, at most, the first 32K, and even then, most programs don't use the full 32K, and especially because not all of it is going to be code, right? One thing I should also mention is that the way this is being done, they would not correctly support bank switching. That's something I was thinking about the other day, was how, you know, Vectrex. So the Vectrex itself, like there are no games that came with it that do any kind of bank switching, but there are modern games that use bank switching, and if you do that, then what ends up happening is you have multiple times the same address mapped to the same source, assuming you spread your code into multiple banks, and that becomes much more complicated. So having a simple address to source line mapping wouldn't work anymore. I'd have to know about which bank it's part of and all that. So that's a bit complicated. I'm not going to worry too much about it. I don't know how many people do this. I think bank switching is mainly used to store data and not so much code. But again, I could be wrong. So if ever I need to face that problem, I'll address it then. Okay, so now if we look at let's bring this up here. This is a quick watch. So in here we should have our debug symbols. So you can see there's 65,536, but you know, a lot of it is empty, but you can start to see so first of all, it'll be totally empty at the end here. Like the last 32K should be empty. So again, totally wasteful, and probably I could reduce this to just the first 32K and we should be cool. Unless somebody provides writes a C or a C++ version of the BIOS, which sits in the top 8K, I think it is. I don't think we're ever going to need all of this address range. But if you look inside the first bit here, you can start to see that right here we start to have, looks like at offset 149, we have, empty file. That doesn't look good. Actually, the fact is, file looks like it's always empty. So that's okay. That's a bug. So let's go take a look at that. So what did we do here? So here, st source file. So that's the source file that I'm matching here. So yeah, one thing I didn't do was make sure that our source file is valid at this point. Okay, so let's put a little breakpoint here and see what this looks like. Oh yeah, look at that, it's empty. Why? Excuse me. Been carrying this cold for way too long. All right, so here's our st source file. So it's source base.h. But then here it's empty. Why is it empty? Okay, we'll try that again. F5, so here we're parsing these guys. Oops. Then at one point we get back to here. What am I doing? We set the source file to this, so that should set it. Oh, it's not setting it on the state. Oh, am I not capturing by reference here? Oh, I am. So there's state. Oh, did I do this one wrong? Oh, okay. My bad. So I wrote this utility function called visit overloads, just because I didn't like how everything was formatted last time. So what I did was, this was the thing we had done last stream, which is like create that overloaded class. Then I made a make overloaded, which is a function that just, it's one of those generating functions that creates the class based on the input parameters. And then I wrote this convenience function called visit overloads, which is takes the variant and then takes all those callables and does a visit of the make overloaded of those callables with the variant. So it's sort of like, it's what you see here, just kind of makes all of this pattern really easy. But I stupidly captured a variant by value here, and that's not good. So this really should be a ref. Now it could be a const ref, so in that case what I'll do is I'll make it a R value reference as well, as I should be doing for my t's here, now that I realize it, right? So it should be like this, and I should be doing, because I'm already doing a forward there, so that should have been R value reference, and the same thing here. So stood forward of variant t of the variant, like that. So now everything's going to be fine. It's because basically what was happening is I was capturing it by value. So the state object that I had here was not the one from the outside. It was a copy of it. So I was storing the file name in a copy of the state, which then would get destroyed when the function returned. Which, yeah, it's not great. So now it should work. Another thing I'm realizing is that I'm wasting a ton of memory by storing the file name, a copy of the file name, in all of those address in that location block. So I should probably do something where I have one place where I store file names, and then I have an index into there or a pointer into there. That I think would make a lot more sense, just for memory and all that. Okay, so here, for instance, we see that we have our state. We're going to set the source file on it, and the state that's on the outside now has the source file in it. So if I hit F5, when we're about to create this guy, we now have a source file and a line number. So that looks good. So we can let it run. All right, here we are. So now if we take a look at our debug symbols, there we go. So you can start to see, this address is mapped to simple allocator line 6. This one as well, this one as well. You see? And then these ones here to source vector list CPP, and so on and so forth. So yeah, this is what I was saying, is that this is actually quite expensive. All of these are strings, and these are a copy of exactly the same string, which is extremely inefficient, given that I'm copying them everywhere. So I won't do it now there, but it's something I could do. I'll just put it in before I forget, I'll just put it in the debug symbols header, and I'll just put a little to do here. Expensive to store same file string for multiple entries. Make a table of file names and store a pointer or index or pointer to them, to it. Okay. Very nice. So what's next? So last time I was talking about maybe making use of this for my debugger, but I feel like we've spent enough time on my old debugger. So let's try to get cracking on the actual debugger itself. So what I'm gonna do is commit this. Yeah, let me remove those printf lines. Okay, so what have we done here? Add. So so just let me check something. Right. I'm just going to reset here because I actually have a bunch of changes that go here. I think what I'm going to do is basically, I've been working on this branch called debugger improvements. I think that we could consider what I've done so far debugger improvements, and now we're going to be starting really on the DAP work. So I think that's what I'm going to do, is make like a new branch for this work here and call this for now just DAP. I need to get some water. Just gonna finish this. I'll go get some water and then we'll continue. All right, so what is this? This is a whole lot of stuff. I don't want to check that part in. So I'll put here add basic scaffolding for DAP debugger, RST parser, and debug symbols. What was this change I saw here? This formatting change is kind of weird. Base.h115. I guess that's a Clang formatting thing that might have changed. I know that there's a Clang format update that I did recently, so maybe that's related. That's a bit annoying when you change version of Clang format and it makes minor changes to your existing formatted files. Just having a talk about that today. Okay, so before I proceed, there was this thing here. Yeah, I gotta do something about that. All right, let's do this. We'll go to master. So here we are on master. I'm going to merge in debugger improvements. Great. And check out DAP here. I'll rebase it onto master. See if it's smart enough to figure this out. Yep. I wanted to see if it was smart enough to figure out that all of those changes had been merged, and it was able to see it. So that's great. Okay, so at that point, I'm just going to basically push master here. Great. And I can delete this branch. And I can delete the whip remote branch. Just a little bit of git cleanup here. All right. So we're back here. So everything looks good. And I want to just apply that last stash that I had. Yeah, this change here, it's something I need to do properly, but right now what I was doing was I was forcing the SDL-GL swap interval to either adaptive vsync or vsync. But it looks like when I do that, I get a pretty big performance hit on certain machines, like my laptop. And I think even on this video card, I got a new video card, by the way, since in the last, I don't know, what, 6 months or something. Mainly just because I wanted something not too expensive, but that could do hardware encoding for streaming. So now I no longer am using, you know, what was it, like 40% of my CPU with OBS, because it was doing all the encoding on my CPU. Now it's OBS uses about 10%, and I can see the GPU is crunching at 83% for OBS, doing this. Doing all this hardware encoding for the video stream. So that's pretty cool because it frees up my machine and I don't have to upgrade it. So, all right, so let's go back here. Make sure that builds. So, okay, so while this builds, I'm just gonna go get some water and I'll be right back. All right. So Jono, you're asking what card do I have now? Nice performance boost. Yeah. Well, I mean, honestly, my computer is pretty crap. That's the thing. It's really old. It's really weak. But you know what? It's good enough for what I need to do. But to answer your question, let me go check my display settings here. So what do I have? I don't even remember. So apparently I have a Radeon RX 570. If that means anything. Yeah, it's pretty good. It was affordable and you know, gets the job done. I basically, like, that's the thing with computers, you know. There was a time where like I would upgrade my computer very often, you know, every couple of years. It was very expensive. But I feel like, you know, unless you're doing high performance, multi-parallel computing, there's like less of a point, you know, or I guess if you're playing a lot of modern games or something, but I'm not. So, you know, this machine is so old. I don't even remember what it is anymore. I don't even remember how to check. What is this machine? So it's it has 12 gigs of RAM, right? It's got I think 4 processors. Like I think it's a 2-core dual core. The dual core. Each core has 2 logical cores. So it's basically 4 logical cores in total. It's an i5 CPU 750 running at 2.67 gigahertz. So yeah, this one's really old. I think this computer is like, I don't know, 8 years old. However, to be fair, I have done some choice upgrades along the way. Like I used to have a mechanical hard drive. I upgraded to SSD. Obviously, I upgraded the video card. I bought new monitors. So you know, I bought these new keyboards. So I'll do little things, you know, for quality of life stuff. But for the most part, the core of the CPU has, like the core of the machine hasn't changed, and it hasn't really made a big difference for me. You know, I'm writing these emulators that are trying to be high performance. So I try not to, you know, not to rely too much on having a really powerful machine. Though I will say that one thing I can see is like build times are a bit slower. You know, if I had a more modern machine, I'd probably be chewing through those builds in like a second or so, you know? And now, like if I touch a header file, it takes, you know, 10, 15 seconds. So you'll see that, because that's parallelizable, but I don't get much parallelism on this machine, so. So yeah, I used to upgrade. My laptop is more powerful than my desktop because I bought it, you know, a couple years ago. Yeah, 2 monitors is like I need it. I've had 2 for a long time now. I was talking about that with people at work. So some people at work opt to have like one, you know, giant 30-inch monitor, and you can either do that or you can have 2, let's say 24 or 27-inch. I forget what it is. And I went for the 2 because I just work better with 2 monitors, you know? There's something where my brain sort of splits tasks. Like I have my second monitor here in front of me. I'm using it for streaming, where you guys see this monitor here, but I have all my other stuff running on the other side here, which is also super useful for streaming, by the way. Highly recommend if you stream to have 2 monitors. Okay, I guess we should get back to this. So all this is working. So I think this is the point where we have to start looking at getting cppdap, integrating it into the project, and starting to do some implementation with that. All stuff I have not done yet, so it'll be interesting to start doing that. Yeah, so this is all working. Great. You have 2 24-inch screens at work. My home monitor is a 2x27-inch, much better in real estate. Yeah, so me, it's the opposite. These screens here are both 2x24, and not super high res either. Good enough for what I need at home. But my work monitors, I think, are 2x27, like super high res, you know, like modern displays. So these ones here are just like 1920 by 1200. I do appreciate though that my monitors here are 16:10 ratio and not 16:9. I have to say I really do like 16:10. Unfortunately, they don't really make those displays anymore. Today it's all 16:9s. I think my work ones are 16:9. Yeah, it's kind of too bad, you know, that the 16:10 ratio is sort of disappearing. All right, so let's go take a look at cppdap. Okay, so here it is. So yeah, just a little plug. I did mention this before, but this project is a C++ 11 library implementation of the debug adapter protocol. It's written by this guy, Ben Clayton, who is actually a colleague of mine. And you know, he doesn't work out of the Montreal office, but we chat like daily. He's part of our team. He's been, or at least partially, working on stuff that we work on. Really smart guy. It's really high quality software, so you can I definitely recommend checking out his stuff. Okay. So I've sort of looked at this a little bit, but I haven't actually used it. So it's easy to integrate into CMake, so we should be doing this. I'll add a submodule to it and do the add subdirectory dance to bring it in. And I guess we'll get started with that. I know there's an example. I was sort of looking at this example of his here. In fact, you know what? It could be kind of maybe instructive to start with just getting the example to work on this machine, and then we can take a look at integrating it. Because I sort of want to give you guys a feel for how this is going to work with, you know, Visual Studio Code as my, you know, text editor debugger thing, and then we'll be able to do the same thing. So let's say I git clone. I have like I'll just do it here. So we'll git clone cppdap here. Do I need to do? I think I do. Okay, yeah. Getting Google test and JSON here. So let's see. Right. So once we've got it, we're going to do some CMake building. We'll specify to build the examples. And also, this is cool here, install VS Code examples. So it installs the cppdap examples as Visual Studio Code extensions. I'm going to do this so that you can see how that works. It's pretty neat. So did you say 1610 is more popular these days? So my understanding is 16.9 is more popular, and that 1610 is sort of going away. But maybe I'm wrong. Okay, so we got that. We'll make a build directory, and we'll do a CMake. We'll pass it build examples and install it into VS Code. Yeah, I don't know. All I know is these screens are 1610, and I'm pretty happy about that. All right, so we got that building. I mean, we got that generated anyway. So let's do a CMake build. I could use Visual Studio here, but there's no real need. We'll just use CMake to do it. So CMake, basically, when you do -- build, it invokes whatever generator you use. So in this case, it's invoking Visual Studio. All right, so there we go. That was pretty fast. So you can see here at the bottom that it built hello debugger. So there's the executable. And it did this custom rule. Okay, I guess it doesn't show it here. But somewhere here along the way, it should have installed the extension. So if that's the case, I think we just need to maybe, I don't know if I need to restart Visual Studio Code. Let's go take a look at the extensions. Oh, here it is. So there we go. So it just totally installed it. which is really just copying a file into some location. It's not very difficult, which is good for us because we're going to want to do the same thing for Vectrexy. So you can see here cppdap example hello debugger, and that's it. So it's installed, right? Now, if I recall, the way to run this is to run hello debugger like this. Okay, so this is running. It's waiting now for VS Code to connect to it. So how does that work again? I think I have to do debug. Don't remember how to do this. Okay, this guy's running. Oh yes, yes. Basically, I want to, yeah, there's a way to say to attach to the, is it in here? We should add it to the documentation here. But it's actually a VS Code thing. VS Code attach to DAP, Yeah, I think it's in this, on this page, where this is basically a page that talks about, like, you know, DAP and for a Node.js extension that you could write, and it sort of walks you through it. And I think in here I saw somewhere about attach. No, it's not attach. Mock debug extension, also useful. They have their own VS Code mock debug extension here. This is a little bit more complicated though, so maybe that's not what I need. Let me see. Here it is. Oh, that's it. Set a breakpoint at the beginning of the method. So I think maybe that's what I need to do is, oh man, how do you do this again? Maybe I need to open a folder. Okay, let me try something. Let me try and open a folder. I think I can open any folder. It doesn't really matter. Like, I can open, let's say, a folder in temp. Yes, exactly, Moosey Boy. That's exactly it. I need to add a launch configuration, but I think you can't do that without a folder open because it needs to put that tasks.json or the launch.json somewhere. So now I think if I hit F5, just kind of create one of these. I think I got to change this to an attach one. I thought there was like a way to create a configuration without doing it this way. Ah, there we go, attach. VS Code extension development. Chrome attach, Node.js attach. What does this one do? Oh, there we go, launch extension. But this is not actually the same thing. Even though, yeah, no, this is more like you're developing. I'm gonna have to look at that one. But what I wanted to see was maybe a, it's not really GDB, right? Let me try one of these just to see what happens. I think that the key is actually the, is it here, set breakpoint at the beginning of the launch request in file, and the last step, configure the mock debugger to connect to the DA server by adding a debug server. Let's just copy this. Is this right? Oh no, okay, this would be at the top here. So it's more like this. Okay, let's try this. So we do a cppdbug. Do I need a program for an attach? I totally had this working and I don't remember how I did it. This was a couple weeks ago. Right, this is the package JSON file. So this is the file that is on the other side. Right. I'm going to have to read this all over again because I think there's a lot of information in here. But yeah, this really almost should work. Maybe what I'll do is for the program, I'll point it, because I know that this test here is supposed to be pointing at a file. So let's go look here. Build debug. Oh, hello debugger. Yeah, I don't think I need to point it at this, but I will anyway, just so that it has something. Looks like that auto escaping didn't apply here. Oh, I think it's because it's trying to launch. Oh, maybe that's why. It's just trying to launch this guy here. Okay, let me try to break that out just to see what happens. Connection refused. Okay. So now we're getting a bit closer. Did I maybe use the wrong port? It's possible. Let me go look at hello debugger here. I'm going to open code on cppdap here. Yeah, exactly, Moosey boy. You're absolutely right. I was indeed running the wrong thing. So examples, hello debugger. So let's see, is there like a port here? Yes, yeah, you're right. You can select which one you want to bind to. Sorry, which one you want to run when you do the launch. Okay, I'm trying to remember. How did I get this working? All right, let's find socket, connect, network. I'll find it. Here, this he has a port. Yeah, so the experiment was at work, so it wouldn't help me if I had saved it. But it's okay. I don't mind spending a bit of time figuring this out. It's all part of the process, right? I'm trying to remember how this works. It's basically, from what I understand, is it's running the server and it's waiting for connections, and you just want Visual Studio Code to connect over that socket. So somewhere in here, I should find what I'm looking for. Oh, hold on a second. Sorry about that. So Moosey Boy says, by the way, why have you switched to VS Code? I only do web stuff, so I have no idea. Are people starting to like VS Code more for C++ for its simplicity? So I haven't switched to VS Code. You can see over here Visual Studio proper is what I'm using for Vectrexy. I am using VS Code when it makes sense. So for instance, for Vectrex, like making Vectrex games, so this Vectrex Pong thing, it makes sense to use something like VS Code just because of the fact that it's got like these. I actually really like the task system, and with it, it's very easy to like set it up to do things like run Docker, and that's how I actually. Like I created these Docker images with the GCC 6809. This is like the fork of GCC that's been made for being able to compile code like C or C++ into 6809 binary, which is what we need for the Vectrex. So I made these Docker instances, and then I wanted to have a way to like kind of build easily. I also like made a task to launch Vectrexy itself. So my emulator with the path to the bin file that we generate, so it's all kind of integrated in there. So that it makes it really, really simple, So like you'll be in the main file here, and this is the code for this like Pong game that I put together, and like you can literally just Control-Shift-R, and it'll execute this Docker build, and then it'll run and it'll launch it in Vectrexy, and there you go, you're playing Pong. So this is a bit more difficult to do in Visual Studio, which is, it's possible, but it's not really meant for that kind of thing, whereas VS Code is more of a text editor with like lots of extensibility. So for that, I really like it. And I just think it's a little bit easier to just kind of mess around with. this DAP stuff, I find it easier to use Visual Studio, again, for the same reasons. Visual Studio Code. VS proper can also be used to do the DAP stuff, but I think it's more difficult to configure it for that, you know? So I don't know if that answers your question. I also have to use it, or I guess I don't have to use it, but I use it on Linux because there is no Visual Studio proper on Linux. So I like to use something I'm much more familiar with. So I will use it on Linux and on Mac. So yeah. But on Windows, if I can, I use Visual Studio. Oh yeah, tasks are amazing. You should totally use them. One nice thing about tasks as well that I set up in here was dependent tasks, which is exactly what just happened when I did a run. So when I try to launch Vectrexy here, I have here it says, where is it? Depends on make Docker, right? And because it depends on make Docker, then it'll run this make Docker thing, right? And it's probably like a smart way to also tell it, like, do I need to run it, by telling it what the output is, and it'll check timestamps. I haven't really done that kind of stuff. But right now I just have it so like I can either build or I can run, which is build and run, you know? Just that alone is pretty nice, I think. All right. So what's going on here? Why am I not figuring this out? So session, maybe I could see how we create the session. So we do create the DAP server. This is setting all the stuff up for it. Whoops, I think I accidentally hit Control minus. That's not what I wanted. Okay, so it's using these content readers and writers. What is the trick again? I've totally forgotten. Is it not using the socket? Server, impl of a DAPnet server. So there must be this here. Basic TCP server, implements DAP client or server endpoint. Okay, server start. That's for network test. Network. Hey, thanks, Moosey boy. Have a good night. I think I broke VS Code. feel like it's not supposed to be this complicated. Like I should have seen it in my list of debuggers. Let me try something. Reload. I think I reloaded the wrong one. Okay, so let me look at this here. I thought I would have seen it in this list here. It's kind of weird. And did I get back? Here we go. Just close that. Okay, let's try this again. So basically the idea is that we've got this session and we're binding on in and out, which are actually reading on standard in. All the handlers we care about have now been registered. We now bind a session to stood in and stood out to connect to the client. Why is that? How does that work again? I think that's what I'm missing here. It's something where we communicate over stood in and stood out. I thought so. I thought so. I am totally missing something. It looks like it's not actually using sockets here. It looks like it's basically waiting for stood in, which means that there's probably a way. That's what I forget. VS Code DAP. A way to make it talk to it. Oh, here we go. Let me see here. Debug adapter executable. This object describes a debug adapter as an external executable with a path and optional arguments and runtime. The executable must implement the debug adapter protocol and communicate via stood in and stood out. Ah, okay. This is VS Code's default mode of operation. And VS Code uses this descriptor automatic. Okay, so you know what? Then probably we do need to point it at the executable itself. That's probably what I'm missing. So let's go take a look here. Where did I put it? Oh, I guess I closed it. So that's that guy. That's this guy. Okay. So let's try and point it at hello debugger like I was trying to do before and hit F5 and see what happens. Now let's do launch. Why? Do I need to run it myself? Oh, let me close it. See what happens. Nope. So I think right now it's parsing that standard input, and I don't know what I'm supposed to do. Let me keep reading on that page. I'll probably find the answer. Is this, I don't need to set this, right? So this is for developing. See, this is what I don't understand is they say that when you go to debug here in the gear, I should have been presented, I believe, with, due to the extension, I should have been presented with a way to create a debugger for, I think anyway, for this guy here. See, because it is a debugger, it's got this here. So I should have been able to do that. Oh, what's this? Type. Oh, maybe that's why. Okay, type hello debugger. So maybe that's why. Let me try that. This is actually in the launch.json of cppdap itself. It's not run task, it's launch or something, right? How do I select which one? No, not from there. Okay, basically I want hello debugger. Ah, there we go. Okay, I understand now. Basically, the key is this type here. I was using cppdebug. The key, it actually is the key. This is registered as part of the extension. So you remember I was saying that like the example has, like, I enabled the CMake property that said like install, and installing it basically registered this type of debugger. I think if we go look again here, there's the type. The type is hello debugger. So just by specifying that we want to use hello debugger, you know, it's configured to just do the right thing. I guess it knows which file to launch, and I think we could see all of that in this package.json file. So let me go show you guys that. Right. It makes sense when it makes sense, you know? Oh, wrong. I have too many VS Codes open. No. Where's the VS Code I had open for dummy cppdap here? And then I want to look at, what is it called? Package. There we go. So this is the package.json file. So I'm going to be writing one of these myself, right, for Vectrexy. so that we can have a way to easily install this like Vectrexy C++ debugger. And basically you need to fill in, there's a whole bunch of other properties that can be filled in, but the key here is, apart from the name and all that, and the type somewhere, display name, description, version, preview, publisher, author, license, engines. So categories, I know this is super important. And then in contributes to debuggers, you got to write stuff here. So it looks like here he said program, targets, cppdap, os, exe, ext. Okay, so yes. All right. I remember. The install step in CMake actually replaces, like it goes and replaces target here and cppdap, os, ext with the specific locations of where you've built your thing. So I'll show you that if we go look at CMake, install VS Code examples. So here we go. So in env VS Code, so in my user profile in VS Code extensions. So let's go look at that. User profile dot VS Code. Here we go. So in there is an extensions folder, right? In here, these are all the extensions that I have installed in VS Code. So in here is Google cppdap, blah blah blah. So let's go in there. And as you can see, it actually copied the executable there. So I don't know if in my case I would do that. Most likely I'm going to write one where you point it at your instance of Vectrexy and then it does the thing. Or maybe, maybe I will package Vectrexy along with the extension. This way, people who want to debug just install the extension and start, debugging. So I'm not sure. We'll see. But basically, if you look at this package JSON, it's the same one, but with things replaced. The same one as this guy. So there we go. So this one's been replaced. You can see it replaced with the name of the target. It replaced with the name of the executable. Oh, I see, the extension. So it's basically hello debugger, then the cppdap os exe extension. So on Windows it's .exe, and on Linux it'll be nothing. And then that's it, right? There's a couple of other things up here. So target gets replaced with hello debugger everywhere. So if you're making a second example, you can give it a different target name and it'll do the right thing. So that's how it knows. This is how it knows that when you say, I want to use hello debugger, the program it runs is that hello debugger that's right next to it. And then it's basically VS Code launches it and then starts talking to it by speaking the DAP protocol to it using stood in, stood out. And then it starts responding. And let me actually, we actually didn't step in, but let's run it again. So what this debugger does is really simple. You can see here that we are in some file called hello debugger source. That's the name. It says hello debugger. This is a synthetic source file provided by the DAP debugger. So that's one thing that's interesting about DAP is, like in most debuggers, you have to have a source file somewhere on your hard drive that you open and you could set breakpoints, which is still what we're going to want to do. But you could also just serve the file itself. That's one of the things you can do in the protocol is you can say, here is a string that represents the source file. So just show this. And this can be useful for things like remote debugging, right? Where you're connected to a remote machine. You don't necessarily have the source locally, but you want to be able to see it. It provides that mechanism. And this is what's being used here to basically give us a synthetic source file. It's not a real source file. It does not exist anywhere on the disk. I know this because if you look at the code, you'll see. I'll show you how this is done. You can set breakpoints and single line step. You may also notice that the locals contain a single variable for the currently executing line number. So over here in variables, you have locals, and there's some variable called current line of type int, and it says 1, which corresponds to line 1. So like I say, I do F10 to step. We actually step to the second line, and current line here became 2. We can just keep stepping, and in this case, it just keeps looping forever. You can set breakpoints. I'll set one here on attempt to set a breakpoint. For some reason, the breakpoint's not working, which is really strange because it was totally working. Add. Oh, I think it's just not. No, it's not. It's not working. Function to break on. So I don't know. I don't know why that's not working. That's a bit strange. So now I'm running. I can pause. I'm here. Yeah, very strange. See, toggle breakpoints doesn't add anything. Oh, something to look into. Anyways, so let's stop this for a second. If you just look quickly at the example, so example, hello debugger. So we'll be building something very similar to this. Like this is like the DAP server code, right? The idea is the synthetic file that we were looking at, if we look for it, is hello debugger. There it is. So the source content here is just a string. That's a raw string, and it has exactly those lines of, those lines that it was showing to us right here. And then basically later on, there is one of the requests that was implemented here is, and this is how it works. You basically register a bunch of handlers, and based on the type of the handler, there's a whole bunch of overloads. You're saying, I would like to register a handler for source request. And if you want to see what source request is, we just open this link, which was provided. So the request retrieves a source code for a given source reference. So yeah, it's what you expect, right? So you come in here and then you say that this guy returns a response or error of source response. So the goal here is to go and implement this so that we create a source response. We set its content to the source content, which is that string we saw before, and then you return it. So you can see that's really nice because it's the way it's been modeled is that you just have this session and you just go and register a whole bunch of handlers for it, and then you just sort of run the session, and it will, whenever DAP makes a request for something, one of these handlers gets called. It's running on another thread, it'll get called. So there is some thread sync to do. There's none being done in here because everything is pretty much on one thread. But if I'm running this in Vectrexy, I'll want to make sure that there's everything works correctly across the threads. So this thread will come, it'll have a handle. What I might do is I don't think it's a big problem because for the most part, Vectrexy will just stop running and effectively be paused, while these things are being handled. So I'm gonna have to do some kind of lockstep thing where it'll make a request and then I'll say, let's say step, right? It makes a request for a step, so I'll on one thread, and then I'll say, oh, okay, I'll maybe have a queue of commands or something like that. You've been asked to step, and then on the main thread I'll step, and then I'll tell it, okay, I stepped, and then it'll proceed, something like that. In fact, if we take a look at step, whoops. So this is there's a debugger, really simple debugger implementation. Step forward here. Oh, and actually you can see there's some mutex stuff going on. So there is some thread safety. And you see what step does is it just changes the current line. You see it wraps around. And then it calls on event stepped. And this on event, whoops. I'm not used to the shortcuts. So this on event, what does it do? Okay, so the debugger is given an event handler. That's how this works. And the debugger instance is here on debugger event. So that's this guy right here. So whenever the debugger says, I want to send an event, it calls this function and it says stepped. So then what we do is the debugger has single stepped inform the client. So you can see what it does. It's going to send a stopped event. That's how it works. So the client tells the server that it wants to step, that it wants to stop, and that it's doing it for step reason, and then it sends it over the session. Similarly for breakpoints, you say I want to stop for a breakpoint. Similarly for paused, the debugger has been suspended, inform the client. Okay, so that's step. Now let's see where it actually gets registered. So step forward. So here we go. So let's say VS Code, you do F10, right? It's going to send the next request in. And so when you receive this request, you basically step yourself forward and you return next response. So the default next response. There's like nothing really to say. We just want to send a response saying, okay, we did it. You know? So it'll be something like that. I'm still not sure, exactly how I'm going to do this, because right now I have this like main thread and I've got this debugger there. I don't know if I want this other thread to be, controlling it, or whether I'm going to do some kind of like sync where dap makes a request and I'm thinking maybe some kind of like queue, or what's the next command that it needs to process, and then on the main thread, if there's a command, it'll do it. I'm still not sure. I got to think a little bit about that. Probably go for the simplest thing first and then see how that goes. But yeah, like does this seem somewhat clear? So what I'm going to need to do then, I guess maybe I have a little bit of time. I'm going to try to integrate cppdap into Vectrexy. Oh, thanks, Jono. I don't know who I'm asking. I'm asking, I guess, myself, but does it make sense? I think so. Makes some sense. So let me see if I can get cppdap into Vectrexy. All right. So what I want to do is I'm going to add it as a submodule first. The reason why I doubled these up was so that I could do certain things, like, where is it again? Oh yeah, to add CMake lists. I may not need to do that for cppdap, as it has its own CMake lists. So yeah, maybe I don't need to do this. So if I look at it here, yeah, the root folder has everything it needs. So I can just grab it directly into a cppdap folder, and I will put the path to that version because I don't need to fork it. So where is it? That's funny. exact same line length. Okay, so that should grab it for us. So let's just see that happen. Can even do it from here. Update all submodules. Okay, so there's cppdap. Did it like actually not do the thing? It didn't actually grab it, did it? Hey, Danny Fritz. So what is a STABS? I guess you're asking because of the title of the stream. So STABS is basically a debug format. It's right here, I think. There we go. STABS. So sometimes written STABS is a debugging data format for storing information about computer programs for use by symbolic and source level debuggers. In this case, we have a fork of GCC for being able to develop Vectrex games, and this fork doesn't generate ELF and dwarf. It generates these text files that contain STABS info in it. So I have to parse that stuff to like collect the debug data that I need in order to write my debugger. Yeah, so why am I not seeing this module here? There's cppdap. Did I do something wrong? Submodule cppdap path external. Oh, that should have worked. Did not match any file known to Git. Git. Nope, not sure what I did wrong. Normally you add it here and you do a git submodule. Maybe I needed to do an add. Normally that's what I just did manually is what the add is supposed to do. So you do add repository and path. So it's repo and path. Oh, okay. All right, I'll do git submodule add and try not to modify files directly then. All right, so external, so there it is. Great. So next thing is we go modify the CMake file for the debugger here. And go reread. Whoops. Why do we need to add this? Oh, I see. Okay. Fair enough. This will define the cppdap library target, which you can pass to, yes, perfect. All right. I do this, and then we add subdirectory. Oh, I see. Okay. I guess I could have just done this, and I think I will just do that because I don't really need that. So let's do an add subdirectory this way. And we will say that we privately depend on cppdap. See how that goes. So if this works, we should see it also appear in the CMake targets over here. CMake error, okay. Add subdirectory given source file, which is not an existing directory. So I got this wrong. All right, it's not current source. I need to use basically my root folder. So that's project source directory. That's better. Okay, so still another CMake error. Not given a binary directory, but given the source directory. What? Add subdirectory not given a binary directory, but given the source directory, e data code active Vectrexy externals, is not a subdirectory of e data code active Vectrexy libs debugger. When specifying an out-of-tree source, a binary directory must be explicitly I see. Huh. Interesting. Interesting. Yeah, this is the first time I do an add subdirectory of an external, right? Isn't it? Is it? Let me see something. How did I do it for line noise or knock? Those I think are in base, right? Core. So there's my knock. Wait, what? Ah, I see. Okay, so I guess, okay, this is what I did is I added externals in my root CMake file because then I can, that's the way to do it, because otherwise you can't be inside a subdirectory and try to add it on the outside. That's fine. So we'll do it here. I'll go back into my, this is just CMake stuff, you know, fun CMake stuff. And probably I'll guard this with something at some point, like, you know, oh, and I don't need project directory. There we go. And then I need to remove, save this. Oh, there we go. Finally worked. Perfect. So there's cppdap right here in the list with all its in all its glory. So now if I build, it should build it. Let's start with that. And it failed. And the reason why this is failing is because I need to do a recursive init of my submodules, right? Because this guy depends on others. So let me try and do an update here recursively. There we go. I think my instructions for cloning should at least mention to do that. Ah, there you go, get clone recursive. So if you do that, you'll get everything. Okay, so we go. We're getting Google test, we're getting JSON. Technically speaking, I don't need the Google test one, but it's all right. Okay. By the way, this little section here in Git extensions, this is a feature I wrote a while back, and I love it. I love that I can do this, expand all the submodules and see the dependencies. You can go there and you can update a specific one. You can even like do open, and it'll open that specific like module. And you know that now I'm in the repo here of that module, you see? In fact, if you just double click on a module, it'll do that. So this is Google test, and even shows you where we're at. It's really quite useful. So I come back here to Vectrexy, we're back to where we were. So nice little feature. Another feature I added when I was working on there was this move up, so that you can actually like decide to put it up here if you like, you know. Somebody on the team really wanted that. Okay. So now if we build, it should actually build. Yeah, there you go. You can see that it's got JSON include in there. So it's building the JSON stuff. Almost there. Build succeeded. So we're good to go. So what this means now is that we've built Vectrexy and we've built cppdap, and I should be able to include it. It's too bad it doesn't actually list its includes. That's something we can do in the CMake file. It's just add the includes to the source list, and then it'll show up in includes. We can do, I can do some pull requests for that. But for now, let me just see if I can include one of those headers, like dap session and all that, the ones we see up here. Let's say I just include these three. Go into our dap debugger, and I should be able to do this. And nope. Right? Or is it working? No, it is working. I think it's just this guy shows me squigglies, but make sure that it's actually building it. DAP debugger, yeah. So I guess that means I should be able to create like a DAP session. DAP session. I don't know if I can actually do that. Cool. Cannot instantiate abstract class. Perfect. Oh yeah, that's right. You got to do create. So I should be able to do this. That should build. Fantastic. And there we go. We even created one. Isn't that fun? Oh yeah, that's debug for you. Okay, this is great. This means that I'm in a very good spot to start working on DAP. But I'm going to stop the stream because it's getting a little bit late. I'm tired. So I'm going to stop it here. I think it's a good place to stop. I guess I can make at least this commit. I can do, yeah, let's do that. Let's commit this. So we've added that. We've added this here. Git modules, cmake. Yeah. What is this here? That's the external thing. And yeah, that's good. And not these. These I'll wait. I'll just say here, add cppdap dependency, or submodule and dependency. Cool. I'm going to push that. So yeah, I'm going to stop here, guys. Thank you so much for watching the stream. And normally I should be back next week on Tuesday. I'm aiming for Tuesday, Thursdays. That's my regular schedule. So yeah, we'll keep on plugging at this next week. So thanks a lot and see you next time.